Greetings, this is Jerry Revier with the Avaya Serviceability Engineering Team. This video today will be talking about sniffer tracing and packet filtering within the H.248 Branch Gateway. This video will be going over the sniffer tracing tool in the H.248 Branch Gateway. The sniffer will allow for packet captures as the gateway receives them from the VoIP engines and the S8300D, which are packet streams that are internal to the gateway. Remote engineers can acquire traces for intermittent issues in a configurable capture buffer. This slide here shows a copy of a text file that I used to prevent SSH traffic from being captured. When troubleshooting, most connections made to the gateway are remote connections using an SSH client. That traffic is usually not relevant. There are two entries that need to be modified. Those modifications follow the comments in red. The entries are the host's IP address, where the SSH connection is originated from, and the other is the primary management interface of the gateway. The last line defines the interface to perform the capture on. This entry is not part of the setting up of a capture list. I retain the line in the text file for my convenience. I set it up to the appropriate interface as needed. I will then be able to copy and paste a complete grouping of text to enable the filtering and the capturing of the correct interface into the Branch Gateway CLI. I have logged into the CLI of the Branch Gateway as a NIT and addressed the ASG challenge and response. I am performing a show running config command to determine if there is a filter list number 501 in place. As shown, that filter list is not currently provisioned. Our first step is to enable the capture service by typing capture-service. I have pre-set up the script mentioned earlier with the correct IP address values for this video. You can see the completed script here on the screen. I am copying the information into the laptop buffer to be able to paste into the CLI. I will now apply the capture list we saw provisioned in the previous text document. Issuing a show running config command shows us that the list was successfully implemented. Going down the output further, the highlighted area is the capture interface line that was pasted in with the rest of the capture script. To save the new capture configuration, a copy running config to startup config command would need to be issued to carry the implemented list over gateway resets. The final thing to be done before we can start the capture is to apply the configured capture list 501 to the captured service. This is done with the command capture filter group 501. We are now ready to perform a capture. To enable the capture, I am issuing the capture start command. To generate some traffic, I will use an IP phone to generate the call. The call is now in progress. To determine that data is being captured, we'll issue the show capture command. I've issued the command twice, and note that the memory buffer occupancy and the packet count is increasing to indicate the capture is being performed. I will now stop the capture by issuing the capture stop command. As shown by the show capture command, the trace has captured some data. To evaluate the data, we have to export the capture. This will be done with the command copy capture file FTP Avaya mentor.pcap followed by the IP address of the FTP server. Something worth noting is that the extension I add to the destination file named .pcap. The extension is not required, but it makes opening the file in Wireshark easier, as that is the default extension that Wireshark uses. I will execute the command, enter anonymous, enter the password. I will go look at the FTP server to see if the file has been saved. As you can see, it is entered there at the top line of the Explorer window. I have double-clicked the file to open up Wireshark with the captured data information. Looking through the capture, we do not see any SSH packets to or from my laptop. We see TCP signaling traffic from the controlling server and the gateway, and then we see a UDP stream of VoIP packets that have been generated. The default capture buffer space is 1 megabyte. If additional buffer space is needed, the TFTP server memory within the gateway can be reconfigured to allow that free space to be used for the capture buffer. Those steps are shown in another Avaya Mentor video. Thank you for your time today. We hope this information was useful. We welcome your comments, questions, and feedback at mentor@avaya.com or on Twitter @Avaya Mentor. Thank you for choosing Avaya.